Our next speaker probably doesn't need to be introduced, as we're seeing him quite frequently on the QA Challenge Accepted stage.
Either as a speaker or as a QA of the Year nominee.
Anton Angelov is CTO and co-founder of Automate the Planet, and also an inventor of test automation framework called BELLATRIX.
He also writes books, consults companies, and gives many conference talks around the globe.
His articles have millions of views each year.
Today, Anton will brief us about many of the most modern solutions for visualizing test results and executing tests in Docker containers.
Your applause for Anton Angelov! Good luck.
Hi guys. I just wanted to say a few words first. This year, I think I beat my record at speaking on conferences around the globe. I think they were around 15. But the feeling when you speak live, not virtually, it's really amazing. So thank you for being here with us, no matter all of the measures and everything. Today, I won't walk so much because I'm going to show you many demos. And I will try, by the way, after many talks, I noticed that it's not a really good practice to explain so much code in depth during these talks, but rather than I'm going to show you tools and solutions that you can use in your day-to-day work, right? And maybe you can try them later and get inspired, right? So, I prepared 6 things to talk about. The first will be about visualizing results. Probably this is one of the most familiar tools for some of you. It's called Report Portal. In a second, I'm going to present it. So the first 3 points are Docker-based. The second one, after that, we were going to talk about executing tests in Docker using Selenoid. Then I'm going to present to you another cool stuff about self-healing tests in Java, again, Docker-based. And the last 3 are more or less connected to the clouds of the big tech giants like Amazon, Google, and Azure, but later on. So it's important to how we can keep secrets, like users, passwords, tokens, etc. It's not a good practice to hard code them in the code. So I'm going to present to you 2 ways how you can manage that. And maybe the most interesting part will be about how to extract information from PDFs and images and how we can work with it in an automated way. So let's begin. The first thing, as I mentioned, that I'm going to present is called Report Portal. This is like a live dashboarding, visualizing your results. Usually the use case is that you will have 1 instance per company, and every team will have a separate dashboard. And it's quite easy, like with 2 commands, you can directly deploy it in Docker or Kubernetes. Let me directly show you how to do that. You can go, it's free and open source, you can go to reportportal.io. The installation, again, it's quite easy. With few commands, you can directly deploy it here to Docker or Kubernetes. Afterwards, they have SDKs for all of the major languages and technologies, Java, .NET, JavaScript, Python, etc. For .NET and for Java, it's almost the same. You just need to install a NuGet package called Report Portal VSTest Test Logger. And the same way like in Java and JavaScript, you need a configuration. Not this one, but here, where sorry, it's a bit hard here to click. So you need here to point the endpoint of the Docker. You need some tokens, and that's it. It's the same thing in Java. And afterwards, when you execute your tests in the CLI, test by test, they will be published in the portal. But let me show you a demo. They have a demo, Report Portal.io, where you can log in with GitHub, and you can generate test data. Again, I believe that the coolest thing here is that you have so many widgets that you can configure. You can display it on the whole screen and maybe visualize it on a television. And you can export it to PDF and attach it to emails to send it to management, right? Also, they have advanced capabilities here to log in with different users with different roles. And they have integrations where you can see the launches test by test again, where, of course, you can see all of the exceptions, screenshots, videos, everything. And since they have integrations with test case management systems and bug tracking, you can directly walk bugs, for example, in Jira, right? Really cool. By the way, keep in mind that in order to install it locally, they have something like 10 Docker images. The requirements are a bit high. So if in the past I deployed it in Azure, and it costed around maybe €100. Again, this is an open source and free tool, but the deployment is expensive. But consider it that it's just one instance per company, so maybe it's not so much big of a deal. Next. Selenoid. What is Selenoid? Probably most of you that used WebDriver already know what Selenium Grid is. The Selenium Grid, many people confuse it that it's some kind of a way for running tests in parallel. No, it's not. Actually, this is a tool that helps you to run through W3C protocol tests remotely on different machines and basically match the exact operating system and browser version. However, there are some paid tools like SourceWraps, what else? Lambda test, many of these cloud-based Selenium grids. They can provide the infrastructure for you, but sometimes it's costly. And this is why some people prefer to deploy it on your own virtual machines and set up the grid. However, there is another option called Selenoid. Basically, this is a Russian version written in Go of Selenium Grid that it's much more optimized. And with a few clicks, you can basically deploy a Selenium Grid in Docker containers. You can have up to 8 containers, 8 browsers per machine. And since they're Linux-based, you have Opera, Chrome, and Firefox, the latest versions. And with a single click, you will have this UI here, where you can watch live what is happening inside the containers. You can have videos and everything, and run up to 8 parallel threads. Also, they support, again, this is open source and free, but they provided images for Google Cloud Platform and other hosting agents. As you can see here, I already use this Google Cloud Platform. They directly prepare the virtual machine. As you can see, it costs around $50 if it's used all the time. However, because they are optimized, these virtual machines in Google, if you don't use it all the time, the price is decreased, and it costs around maybe $30 per month for 8 parallel sessions. In order to use Selenoid, it's just like regular Selenium Grid. You just need to add a few capabilities, and that's it, no matter the language. I mean, it's almost the same, since it's going through the grid. Also, last year, they added an option for running APM tests on emulator inside the Docker containers. It's working, but as you can imagine, because of the double or triple virtualization, it's a bit slow. However, it's an option. And also, you can change the skins of the emulator so that you can test on different devices, right? As you can imagine, this works only for Android. It's not working for iOS. Next, secrets management. I wanted to show you the normal way how people, of course, we all know that it's not a good practice to hard code credentials directly in the code. Then the next option is to put it inside configurations like this, but again, these go to Git, and it's not the best practice either. Another option is, many people do it, is to use environmental variables. And that's fine. I mean, this is like a standard way for storing secret information, because the environmental variables require admin access to the machine, and they're only specific to this particular machine. No credentials go to Git. This is fine. However, for enterprise projects that we are working on, sometimes we have up to 10 or more integrations, and this means that for one integration, we need at least 2 secrets. You can multiply that by your team of QAs, for example, 15, and you can imagine how many environmental variables need to be set up on each one of these machines, which is hard to maintain if there are changes. So another way how you can handle this is to use secrets management services. Basically, these are web APIs. Let me show you. Basically, Amazon, Google, Azure, they have their own version of these APIs. Here, for example, in Amazon, this is called Secrets Manager. This is a centralized place where you put all of your secrets, and you can update them from there. And basically, your code just go and make a request to this Secrets Manager client to get the secrets. In Azure, this is called Key Vault. This Key Vault, we need, again, I just installed one NuGet package. It's called Azure Identity and Azure Security Key Vault Secrets. Keep in mind, all of the examples about the cloud platforms, basically they support all of the different languages, all programming languages, because they are based on web APIs. This is the case in clients. They are only to make the requests easier, but you can basically use JavaScript, Java, whatever language you use. So I used basically their documentation, initialized the secret client. The whole idea here is that you need only to set up 3 different environmental variables on your machine so that you can connect to this storage. And then afterwards, you have a simple method called getSecret, where you just name the name of the secret that you want to get. That's it. And it's much easier. The next thing, self-healing tests. Again, it's Selenium, or maybe I'm not pronouncing it well. It's, again, open source and free tool, Docker-based, developed by EPAM. You can visit their website. Again, with just 2 clicks, you can set it up in Docker or Kubernetes. The whole idea behind it is that when you run a test like this and successfully passes, all of the information about your locators go to this service and remembers, the location and everything. The next time when you run the test, and if the locators are changed, basically the test will pass again, because this machine learning algorithm will match the coordinates and everything in your page, and will figure out the new locator. We have tested in a few scenarios, and it was working just fine. You can give it a shot. For now, it's working only for Java. The only thing that you need to set up, here, this is a Java example, you need just to install one dependency in your POM and a plugin. The plugin I will show you is just to create test results later on. And the only change in the code is that you need to wrap your WebDriver inside their decorator. It's called self-healing driver. Basically, behind the scenes, it's making calls to this machine learning algorithm that is hosted on the Docker, but just in case of failures. And you need, I believe, one file with a few properties, how many times to retry, and all of that. You can check the documentation for more info. It's not so important right now. And again, if you install the plugin for IntelliJ, you can get a report like this where you can see whether the locator was fixed or not. You can see screenshots of success, and basically that's it. I think it's really cool. You can try it. I believe that they are working right now on other bindings to support other languages as well. Now, probably all of you that worked in the web domain are familiar with Google Analytics and other analytics websites. For just a quick reminder, we use the Google Analytics as a big data storage for how many users we have each month, which pages have been visited, how much time, from which countries are our users, and information like this. All of the big platforms like Amazon, Google, Azure, they support the so-called App Insights. Basically, this is analytics to put in your mobile applications, desktop applications, whatever, to keep data like this. And why I'm telling you this? In the first years of our framework, we wanted to lock all of the different exceptions from different machines in a central place that are related to the framework so that we can fix them. Later on, we upgraded the solution so that we can keep track of the different features that people are using, so that if something is not used so frequently, we can deprecate it and whatever. And I figured out that maybe we can upgrade this solution to lock even more information, like information about the execution. What is the name of the test? When was it executed? On what environment? What is the exception, the stack trace, and information like this. The cool thing is, because if it's a central place, this is different than the reports that you publish in continuous integration. Because it's a central storage, you can use it to analyze, because as you can see on the screen, you can write queries similar to SQL, meaning you can filter from all of the jobs, all of the test executions, you can find particular failure and even search inside the exceptions and stack traces. This is not possible in regular reports and filters, right? And this can help you to spot problems and analyze failures. Actually, the usage is, again, pretty simple. Again, this works for all of the languages. I created here a project. You just need a NuGet package, Microsoft Application Insights. Again, this works for all of the platforms and all of the languages, or you can use just their web API. And we have this telemetry service where, again, just reading the secrets, we initialize the client, and then you have just a few methods, track exception, and track event. Track event is something custom that you can walk, like usage of particular feature, as I said. You can track whatever you want. That's it. And at the end of the test execution, for example, in assembly cleanup, you need to call flush so that you can send all of the data so that your tests are not slowed down. And next, maybe the most interesting part, at least for me, is called computer vision. What is the computer vision? Again, let me show you. Sometimes our websites or applications are generating not only invoices, but PDFs, or, for example, sometimes you have to, for example, verify information, like on this particular screenshot here. We were working recently for a medical company, and they had a lot of graphs like this. How do you automate this and extract the information? It's really hard, right? And I wanted to check the dates and the values here, right? This is why the old approach for verifying invoices, PDFs, whatever, is to use tools like SQL or some kind of a custom logic for making screenshots and verifying only the static data on this PDF, right? This works fine. However, my usual approach for writing tests is to generate all of the data and then delete it in the end. This means that I usually want not static data, but dynamic data, so that tests are much more stable this way. We use APIs to generate them. And this is why I wanted a better approach, not to rely on images. And during research, I found services. They are based on AI, artificial intelligence, and machine learning. For Azure, this is called computer vision. For Amazon, this is, again, computer vision. They have the same features, pricing, and everything. For Google, this is Vision AI. And the thing, what this gives you. Basically, they have few features. I'm going to talk more about one of them, the text extraction OCR. Actually, it can understand images as well. Basically, it can detect objects. I played a little bit, not like hacking or whatever, but it works for captchas. So you can work around captchas if you use it. But again, just for testing purposes. And anyway, you can extract text from images and PDFs. It's working fine for around 20 languages. So basically, when you just make a web call to this service, you submit the PDF, and it returns all of the text list of strings, right? And you can verify all of the information in it. Let me show you. Here is the text verification. Again, this service wasn't meant to be used for automated testing. Basically, I just use it for this. But anyway, we can use it. So here I submit my PDF. Basically, behind the scenes, this is reading the local file, and again, using the computer vision client and submit it there. And basically, no matter, you can get it from the documentation. The details here are not important, but the logic. So we are returning a list of strings. This is all of the text from the PDF. Then I'm initializing my expected list of strings. Again, this is the same in Java. And then I created this validate text method. As you can see, it accepts the PDF, the language, and the expected snippets. Behind the scenes, the only thing that I'm doing here is that I'm comparing through NUnit or JUnit, whatever method for comparing list of strings, nothing more. However, there is one big problem with this approach, and that is that, for example, if I check that this price is here, I cannot verify that it's not somewhere else, right? The layout may be broken. So I wanted a way to figure out whether the layout of the PDF is correct, that I have this column, this invoice number is here, right? So how we can handle this? We can handle it through another cognitive service. It's called Form Recognizer. It's similar to computer vision. Again, it's a web API. The whole thing is that when you submit the request, this time the JSON representation is much more detailed. Basically, the service is returning the PDF and the image as a table of data. So you will have the different rows, columns, and their coordinates like this. You'll have the coordinates for each point of the boxes, right? So we can use these boxes to verify whether the layout is okay or not. Let me show you how I built it. Basically here, we have one PDF that it's expected, like it's the template for getting the right numbers that I expect. So this is the first PDF, and the second one is the one that my application generated. The thing that I'm doing inside is that from both PDFs, I analyze the files. They are returned as tables. This is a special collection. Basically, I'm just deserializing the JSON to C# or Java objects. And then I'm working with Java or C# objects. That's it. And nothing really fancy. I'm just checking the coordinates. Like I'm comparing X and Y's of these coordinates with some kind of a delta. In my case, I tried this with a few PDFs, and this delta from 0.1, it's working completely fine. You can change the delta if you want, but it's completely fine. And next, I sophisticated a little bit more the API. Again, as I said, this service is returning the data in a table format. So I wrote new methods for getting cells and rows. And basically here we are using link or stream API in Java to select particular cells or rows. And then you have through builder design pattern, here we have different assertions to check the information in particular cell, row, or whatever. We can get even more complicated than that. For example, I consulted a medical company again, and basically they didn't have any web, rather they had a legacy desktop application, and there they had these big, huge sets of data, right? And we used WinUpDriver to automate all of this. However, WinUpDriver is much slower compared to Selenium, and in order to get, for example, 50 cells, you need 5 minutes. As you can imagine, this is quite slow to verify all of the data. So I wrote for all of our components, elements on the screen in the application, I wrote a method called AI Analyze. The thing that this is doing, as you know, in Selenium, API, and WinUpDriver, you can take a screenshot of particular element. So I'm making a screenshot of this table of data in WinUpDriver, then I submit it to the same service that it's returning the data as a table, and then we can use the same methods for getting lines, rows, data, and verify it in the way that I explained. And this is working like just for 1 second instead of 5 minutes, right? Keep in mind that all of these cloud services, of course, they are paid. They have different pricing. However, for computer vision, I believe the pricing is around 1-2 cents per 1,000 requests. So it's relatively cheap compared to all of the different visual testing tools out there that are promoted, right? But again, these are not meant for automated testing purposes, but you can get expert and try them on. All of this code that I'm sharing here is completely open source. There are different articles on Automate the Planet. You can get all of them if you want. I believe we don't have much more time for other stuff. Organizers can give you the slides with all of the materials, and I can answer now questions, and of course, during coffee breaks, if you're interested in something, we can discuss it, or later on, you can reach me always on LinkedIn, and I will answer and help. Thank you.
Any questions?
Yes, hi.
And if there are any questions in Discord, our volunteers will read them for you.
Hi, Anton. Really
Hi.
good presentation. Well done. I have a couple of questions about report portal. And the first one, if we use the default installation in a Docker, do you know what is the breaking limit in terms of parallel uploads into the report portal system? And if we have multiple users running at the same time some analysis or auto-analyzer is running, when the system is expected to break?
It really depends where you have hosted and on what machine with what requirements. As I said, in the past, we deployed it in Azure on a relatively strong machine like, I believe, maybe 16 RAM and maybe 4 up to 8 CPUs. And then you can support up to maybe 4 parallel runs. However, if the machine is slower, then you experience problems. We had this in one of our enterprise projects, and then we had, there is a way, they have an API for all of the different parts of the system, so you can basically upload the results at the end of your continuous integration instead of submitting the results in parallel. Because we noticed that actually this synchronization with report portal is slowing down a bit the continuous integration execution. So maybe a better approach is just using curl or whatever to submit the results at the end. I believe I'm not using it really, real time. For me, this is just a fancy feature, right?
And for report portal, you have used it just because of the dashboard or because of something else in terms of functionality?
To be honest, I like the dashboarding. If you are in the office and you put it it's really fancy to see it on a television, right? To see all of the results and fancy stuff, because when people get inside the room, they're quite respected by seeing the results. And this is really nice to upload it to emails. But I prefer to use, for example, we are using for continuous integration Azure DevOps, and I prefer to, for my analyzation purposes, to use their results.
Thank you.
Thank you. Any questions?
And thank Nicky for the questions. He's the next lecturer, so maybe we will
we
ask
have
him
questions
also.
on our Discord channel.
One question from
please,
Discord.
don't be in such a hurry. Okay, first one is from Milena Janovska. What is the benefit of using Docker? What if we didn't use it?
The benefit of using Docker, it depends for which solution. If we are talking about Selenoid, as I said, if you compare the pricing, for example, if you buy an account in SOSLab, they really quickly can get hundreds of thousands of dollars, right? If you use your own hosting, it's much cheaper, so it's always about the pricing. Yeah, that's it. Basically, if you're talking about Selenium Grid, because the other tools, you don't have any, you cannot use them in other way, so.
Okay, I hope Milena is happy with the answer. I'm disturbing the technique. Okay, another one from Maria Lambova is helium, I suppose helium, working with Appium.
I'm really not sure. I don't know. I haven't tried it. I believe their examples are only for WebDriver, not Appium.
Okay, we may check and answer Maria later. Okay, Ivaila Simeonova, what is the most suitable tool for mobile automation tests for both operational systems, iOS and Android?
Can you repeat the beginning of the question?
What is the most suitable tool for mobile automation tests?
I believe most of the people right now, the standard is Appium. It's, yeah, basically this is the standard. So.
It's the second part of the question, is it Appium?
Yeah.
It is. Okay, that was the last question. So thank you, Tony.
Thank you.
Thank you.
Thank you.
Thank you. Thanks to Anton, and let me remind you that you can buy his books to support our cause. And now?
And now, break. Coffee break.
See you in 11:30.